morning, everyone, and welcome to our webinar. My name is Bianca, and I'm part of the BD and marketing team. Just some housekeeping just before we start the webinar. We will be recording this webinar, and we will be posting it on our YouTube channel. We will send the details after this event. If you have any questions, please use the Q&A box, and we will have a Q&A session at the end of the webinar. We are hosting this event as part of World Green Building Week. For those who don't know, World Green Building Week is World Green Building Council's annual campaign that empowers us all to deliver greener buildings. This year's theme is Act on Climate, and it's just calling everyone from the building sector, the policy makers and governments to take urgent actions to deliver net zero buildings. Today's speakers are Horia Iliescu, who's the principal engineer responsible for the Bucharest office. He will kick off the webinar, and Simon Wyatt, who's our sustainability partner from London. He will take us through the main presentation. Without further ado, Horia, do you want to start?
Yes, thank you, Bianca. So good morning again to everyone who has joined the call today, and welcome to our webinar. So, triage for an ailing planet. Probably everyone wonders what does that mean. For Cundall, it's about the things we do about sustainability, innovation, or digital solutions. But it's down to net zero carbon and the way that we occupy buildings and the way that buildings of any type are designed, delivered, or managed within the built environment. Cundall as a business has been successful in driving sustainability for many years now across the 25 offices we operate globally. We were the first One Planet company to kind of really live by our own principles of what we've advised our clients and what we deliver for them. So what we do is what we preach, and that One Planet company was a key milestone for Cundall many years ago. Now we are the first carbon neutral company, which also stands as another major milestone that Cundall touched. This followed a certified carbon neutral assessment on a pilot scheme we did in Australia, and we will be fully certified by the end of November. So those two things represent the key message that we're trying to deliver to our clients, that these things can be done. And although they for sure require some investment, they are achievable. We operate globally in 25 offices, so it all depends on where we are present. Some markets are more mature than others in terms of net zero carbon, and people are more educated in that respect. Now, thinking about the net zero carbon for new buildings, it's the easiest way and thing to do, but we really need to be concentrating ourselves on and our efforts on reducing the carbon footprint of the existing buildings, which is at this point probably 90% of the stock of our clients. How we drive them to net zero carbon, it's a real challenge for developers and occupiers as well. Throughout our offices, we operate in most sectors. We have our core services, which is structure, civils, and MEP and sustainability, but we are also providing specialist services. Across all our specialist groups, we embedded everything in what we need to do in terms of net zero, energy reduction, sustainability solutions, and this is bringing everyone in a single journey. Let's say it's one Cundall, one goal on what we're trying to achieve on our drive to push the agenda on the triage. As I was mentioning before, the key problem is the building stock of our clients, which will be the main focus right now. How can we get the best of what we already have? And in our opinion, it's better to repurpose those buildings instead of knocking them down and, I don't know, building something from scratch. So the emphasis now is how to drive the existing buildings to a net zero carbon stage. And my colleague Simon will touch base with this issue somewhere a bit later in the presentation. Climate emergency. Climate emergency requires action across all sectors, and we are increasingly finding opportunities to reduce the carbon footprint in all our sectors. There are more and more clients that are pushing for net zero carbon now across the globe. As a global community, we currently consume 1.7 planets worth of resources to sustain our daily demands. Each overshot day is the day we stop using our fair share of resources and we are starting to borrow from the next generations. This year, for the first time, this day actually moved in the right direction, but this was mainly due to the pandemic and because the the entire world stopped for a few months in April or May. Key to this is reporting and reducing our carbon emissions to help reduce our impact on global climate change. Just as a reminder, we are already on a trajectory of at least 3 degrees global temperature rise, which will have profound impacts on us all, and it's well above the target set in the Paris Agreement, which was 1.5 degrees. It is vital that we act now and we act together to achieve this goal of flattening the emissions curve. Achieving the net zero carbon target must be at the heart of our industry and a response to this crisis. As you've seen over the couple of years, I think it's in the past 5 or 6 years that these things have started to happen. There are the impact of climate change is affecting us all. There are bushfires and the wildfires in California, in Australia. We've seen huge floods in UK. I think it was in February this year. So this talks about that we need to act as quick as we can, and we need to act together. In response to this, the EU Parliament have declared climate emergency and set a target to limit global temperatures to 1.5 degrees in line with the low threshold of the Paris Agreement. To achieve this, they have set challenging targets to reduce carbon emissions by 55% by 2030 and to be carbon neutral continent by 2050. Also, the Romanian Parliament in November last year have declared a climate change emergency, but they haven't set the scene yet on how we're going to do this. In Romania. We're still waiting for measures to be out there so we can implement them in our design and in our lives in general. Now I will pass it on to my colleague Simon, who will take you for the rest of the presentation. Simon?
I am. I'm just going to share my screen. Can you see that now?
Yes, we can.
Yeah.
Perfect. So the question is, what's this got to do with the built environment and buildings in general? Well, buildings in the European Union equate for roughly 40% of CO2 emissions, 11% of which is actually associated with the construction of those buildings. So the carbon associated with the materials they use and the construction activities, and about 30% of emissions in the EU are associated with the actual operation of buildings, so heating, cooling, electricity use within buildings. So we are responsible for a significant carbon footprint, and we need to take action in order to meet the European Union declarations and objectives. To help this, the World Green Building Council, working with all of the local green building councils, have set some challenging targets around buildings. So they've set a target that all new buildings are net zero carbon in operation by 2030, and all existing buildings by 2050, and all new buildings by 2050 considering whole life carbon. So that's including the embodied carbon associated with their construction. To help people understand what this means, they've helped publish a number of documentation which support this. We help put a number of those together, so explaining what upfront embodied carbon is, explaining how to move towards a net zero carbon economy, and how to design these types of buildings. One of the most advanced GBCs is the UK GBC, who have put together a framework for what net zero carbon in the built environment actually looks like, and that is now being adopted by a number of other green building councils around the world. And this is it here, which is basically saying that in order to be a net zero carbon building, you need to reduce your construction impact, reduce your operational energy use, provide renewables on site where possible, and if not, purchase green electricity. And then finally, once you've got as low a carbon building as possible, offset any remaining carbon using grade A certified carbon offsets. The final part of the process is public disclosure, and this is so that the process is transparent, so that people can see what other people are doing and make sure that there isn't greenwashing and people aren't just offsetting energy intensive buildings. This framework applies both to new buildings in design and also buildings in operation. And what's really important with this is the first two, which is the reducing construction impact and the operation energy. And what is happening around the world is people are actually setting intensity targets. So these are minimum performance requirements for the construction kilograms of CO2 and the operational energy kilowatt hours per meter squared usage before a building is allowed to do the renewables and carbon offset if they want to claim to be net zero carbon. So the question is, how do you set a operational energy target? Well, the way it's being done around the world at the moment by green building councils is using a method called the Paris Proof. And that's basically saying, how do we transition to a net zero carbon economy? And when you have a net zero carbon economy, it basically means that all your energy demands are going to be met by renewable sources and there's zero carbon emissions. If we take the UK, for example, at the moment we produce about 20% of our electricity from renewables, and therefore we have a huge imbalance compared to our demand. In order to move to a net zero carbon economy, we must reduce the energy consumption that we need, whilst providing more from renewables until they reach a balance. So if we took a snapshot of that at the moment, currently this is electrical generation from renewables, which is about 20% in the UK, and here's demand, which is very high. In order to transition to a net zero carbon economy, we must reduce this demand while simultaneously increasing renewables. And once the two meet, then we move to a net zero carbon economy in terms of energy. What that means for the industry is that basically, if all industries decarbonise at the same rate, it's about a 50 to 60% reduction in energy demand in all sectors. Obviously, all sectors won't be able to reduce at the same rate, and as we move towards more electric vehicles, that will put increasing demand on the electrical infrastructure. So buildings, in order to meet a net zero carbon intensity target, really have to get kind of a 60 to 70% reduction from what is typical now. So if you take a typical average performing building in Romania and want to make it net zero carbon, the first thing to do is reduce energy consumption by 60% as a minimum. That is known as a top-down approach, which is basically saying what is every building's fair share. A number of organisations have also looked at it from a bottom-up approach, which is basically saying, right, let's take a very good performing building, which has an energy intensity of around about 160, and how low can we actually get that building by implementing all the best practice measures. So things like moving towards natural ventilation, demand control, improving thermal insulation and U values. And once they apply all of the energy efficiency measures, the lowest they're predicting we can get to for commercial offices is around about 55 kilowatt hours per meter squared. So you can see it's a significant reduction from where current building stocks are at the moment, and is really challenging. And this is very closely aligned with the top-down approach, which is that 60–70% reduction. So once we have operational energy intensity targets, the next focus will be on embodied carbon. So this graph is basically showing operational energy in dark blue, and at the moment it's the majority of a building's emissions. But as we reduce the operational energy over time, the embodied carbon associated with its construction becomes more important, and we need to start focusing there. When we talk about embodied carbon, what do we actually mean? Well, there's actually lots of stages of embodied carbon, and the main two are known as upfront embodied carbon and then in-use embodied carbon. So upfront embodied carbon is the energy associated with the extraction of materials, the processing, and their transportation to site, including the site activities, so all the cranes, plant that help produce the building. When the building is built and completed, that is the entirety of the upfront embodied carbon, and that can actually accurately be calculated and reported on that completion process. Once the building is in use, the in-use phase kicks in, and that includes things like maintenance, repair, fit out, recladding, or any works done to the building during its 50, 60, 100-year life. And then we also have to account for the end of the life. So when the building is demolished, what happens to the materials? Are they sent to landfill? Are they reprocessed for recycling? Or can they be reused, helping a circular economy? So all of that is whole life carbon, has to be accounted for when considering the design of the building. Similarly to operational energy intensities, the entire world is looking at embodied carbon intensities. Cundall recently worked with the Greater London Authority to help them set their methodology and targets for new buildings in London. And we did a review of about 50 buildings which had recently been built, and they were averaging an embodied carbon intensity of just over 1,000 kilowatt hours per meter squared. The GLA have set a benchmark recommendation for them for new buildings at 900, and they'll over time move that down. But the net zero carbon aspirations set by organisations like LETI or RBA are showing much steeper trajectories, moving towards 600 and 350, which, as you can see from this graph, not many buildings are achieving at the moment, and is a significant reduction. Again, it's very much in line with that Paris proofing we were talking about earlier, so it's a 60 to 70% reduction in CO2 emissions absolute. Again, what you'll see around the world over the last 6 months is people setting these intensity targets. And what a lot of people have done is, instead of just jumping straight to an end target, they've kind of done a stepped approach. So setting targets for 2020, 2025, 2030 for new buildings, and then existing buildings at 2050. But you can see from this slide the scale of the challenge. So most buildings, commercial buildings, are achieving energy intensities over 200 kilowatt hours, and we need to get down to around about 55. So a significant reduction over the next decade. Similarly, with embodied carbon, most buildings achieving over 1,000 and have to get down below 500. So both of those are extremely difficult challenges and will be the main focus of the construction industry globally for the next decade. Around the world, we've seen significant action and different frameworks and methodologies from different green building councils. And what Cundall have done is we've taken all the best practice and kind of merged it into what we call our steps to net zero carbon. And I'll take you through those now, which is basically a process which you follow in a linear order to reduce the carbon impact of a building. This can be equally applied to new buildings and existing buildings. So step one is passive design optimization. And what do we mean by passive design optimization? This is basically taking a fabric first approach to reducing the energy consumption of the building. So it's a low energy building before we even start putting systems in. And where do we start with this? We start with optimizing the facade. The facade is really important to a building. We need to make sure that we are achieving good connection with outside for people's health and well-being and getting good daylighting. And when we talk about good daylighting, we don't mean wall-to-wall glazing, because that gives us glare, heat gain. Blinds are down for significant portions of the year, so we don't actually get the views out that we want. We want targeted glazing, which gives the views and enables people to have the blinds up for long periods of the time. So for most buildings that are aspiring towards net zero carbon, they generally look at around about 40 to 50% external glazing on the facade. Once we've reduced the glazing, it means we've reduced the heat gains, which means we can potentially naturally ventilate buildings for longer periods of the time. Most buildings in cities have been sealed and don't have openable windows, which means that they are fairly energy intensity during the day. And even when they're not in operation and you have people coming in at weekends or at evenings, they have to run all the mechanical systems in order to keep those few people comfortable. By opening windows, we're able to provide comfort in those extended periods. But what we really want to move towards is more buildings which are naturally ventilated or mixed mode. So a mixed mode building will be mechanically ventilated with heat recovery in winter, and then mechanically ventilated with comfort cooling in summer when it's really hot outside. But for the majority of the year, 60–70% of the time, it runs on natural ventilation, where it has openable windows, ideally cross ventilation or stack ventilation, driving fresh air through the building without the need for mechanical systems. The main focus of passive design optimization is really looking at the fabric of the building. So focusing on insulation levels, making sure we have continuous insulation around the buildings, looking at glazing. So where we have heat-led buildings like schools or residential, we go to triple glazing. If we've got commercial buildings, it's normally okay just to keep with double glazing. But also looking at things like thermal bridging, making sure that we don't have lots of penetrations through the facade. And what's really important and what's been driven heavily in the UK has been air pressure test results and air tightness of a building. The building regulations at the moment in the UK has a requirement to test and achieve an air pressure test of 10 meters cubed per hour per meter squared. But most buildings now in the UK are targeting 1 or 2. So that's a 80 or 90% reduction over the building regulations air tightness. And in order to achieve something called passive house, which is a really good standard out of Germany associated with energy efficiency, you have to be lower than 1, which is basically a fully sealed building, which means you don't have any leakage or wastage of energy. Once we've reduced the energy consumption passively, we need to think about how we provide energy and reduce energy demands and consumptions. And one of the main ways we do that in buildings is looking at set points and how we heat and cool buildings. So typically, especially around the world, there's lots of buildings which will be heated and cooled to the same temperature. So they'll have heating to 22 degrees, cooling to 22 degrees, which means that a building can be simultaneously heating and cooling, which is very wasteful of energy. By moving those temperature bands apart, we're able to save significant energy. So heating to 20, cooling to 24, means that we can actually achieve 10 to 20% energy savings. Also looking at how we size equipment. So generally around the world, when we design buildings, we design them for the absolute worst case. We assume that they're fully occupied. We assume that everyone is using high amounts of ICT, and we've got the lighting on full even when it's sunny. What this does, it means that all the equipment that we install is oversized, and then when it operates, it's operating inefficiently at low bands. So there is a move to do from Australia, the UK and America is to reduce the size of plant and make sure that we're sizing things to work at the optimum performance for the entirety of the year, not just at that peak period. To do this, one of the key focuses is around controls and using smart controls, so putting sensors into the systems, understanding how the buildings are working more effectively, and look for areas where energy is used inefficiently. If you have a large portfolio of buildings, using algorithms and machine learning to review your buildings to optimize performance and highlight where things are out of range. Another major focus of the industry at the moment, in order to achieve the intensity targets, it's really important that we do detailed predictions and simulations during the design process. So there's a standard in Australia called Neighbours, which has come over to the UK under a guise of design for performance, which is very similar to the American ASHRAE standard. And what they require is you do detailed energy calculations at the early design stage to predict your actual energy consumption and optimize the performance of the system's facade and design. And then that is used to inform the design process, commissioning process, and control strategy. And what's really important with it is that you use that data to verify the performance in the first year. So you actually go in and fine tune the performance of the building and make sure you're achieving what you said you do. Around the world, most countries do not actually look at the operational energy of the building once they've built it. They don't fine tune it. They don't go back after they hand over that building. It's really important we make sure that during the first couple of years of a building's life, that we make sure that it is operating as we designed it to do so. With the move towards net zero carbon, one of the most important things we need to do is move away from fossil fuels. So globally, the main heating source generally is natural gas or diesel. And obviously, if we're burning fossil fuels on site, it's very difficult to claim to be net zero carbon. We need to start moving towards electrification or potentially the hydrogen economy. What does this actually mean? Well, it means in most buildings moving towards heat pumps. Heat pumps are generally 300 or 400% efficient, so are much more efficient than direct electric heating. And also looking at district heating networks to provide low carbon heating to dense urban areas. Once we've reduced the energy consumption as much as possible, then we need to look to provide as much renewable on site as possible. Normally, this isn't possible for urban environments. You only have a limited roof area. So if we're out in the rural environments, we can potentially have enough PV on the roof to meet our demands, but most buildings will only be able to produce a percentage of electricity. And once we get large PV arrays, it's worth considering battery storage so that we can actually deal with the times where it's not sunny or we have high demand. Once we've looked at the operational energy, then the next thing to do, as I mentioned earlier, was look at the embodied carbon associated with the construction of the building. So the main focus should be on that upfront embodied carbon, so the actual materials we select and how we actually build the buildings themselves. So if you think about a typical building, you have the embodied carbon associated with the construction of the building, the foundations and the frame. So that's normally concrete or steel. You can use replacements for cement to reduce your concrete footprint. For steel, you can start specifying steel which has been produced from an arc furnace rather than a blast furnace, which uses recycled electricity and recycled steel instead of using natural gas fired furnaces. Or what's being mooted a lot around the world at the moment is the use of CLT and timber. So that's considered to be extremely low carbon because it's absorbed carbon during its life and growing, and actually has a negative carbon footprint. So what you need to do is look at every element of the building and say, can we use different materials, or can we make the materials we're using more efficient, reduce the amount of materials we're using, and then calculate that impact to see how we actually perform against those intensity targets. When we consider carbon, we need to consider it across the whole life, as I said earlier. So one example is being a facade. So if you've got a new building and you build a facade which is low embodied carbon but needs to be replaced every 20 years, it might be better to go for a more carbon intensive building to start with in the first place, but it might last for 50 to 100 years and therefore have a lower whole life carbon footprint. In terms of carbon footprinting and calculations for the built environment, there are a number of methodologies which Cundall have produced. So there's the RICS guidance and REBA guidance in the UK, which set out a methodology for calculating and reporting. Again, the GLA, which have produced a methodology and guidance for calculating, which has been adopted by different councils around the UK and being used internationally now. We've also worked with the Hong Kong construction industry to produce a freely downloadable tool which calculates embodied carbon. So again, there is lots of different activity in different regions, but they're all starting to align. And the final step, as I said, is public disclosure. We really need to be transparent in what we're doing so that people can see what everyone is doing, and also to make sure there isn't greenwashing and people claiming to be doing things that aren't giving the benefits they're actually saying they are. So what we want people to do is to start reporting their carbon footprinting. So when you build a building, you report on completion your A1 to A5 emissions. So that's the upfront embodied carbon associated with the construction. Then on an annual basis, you report your B in-use carbon. So that's your in-use, maintenance, repair, operational energy on an annual basis, and then offset any carbon emissions. And then at the end of a life, if a building is disposed of or demolished, you report the C and D modules. So I'll just finish up with a few case studies. So for new buildings, we've just finished in Australia a building called the Sustainable Research Centre for the University of Wollongong. It is classed as a net zero carbon building. It has been designed with passive design in mind. It uses natural ventilation for the majority of the year, although it does have heating and cooling. It takes advantage of thermal mass and the materials that have been selected are generally natural materials with low embodied carbon. In terms of heating and cooling, it's provided by ground source heat pumps, so there's no combustion on site, and then it has a fairly intensive PV around the roof, which actually produces more energy than it uses, generally about an extra 20 to 30% a year. And that actually is being used to offset the embodied carbon that was used to construct that building. So after, I think it's about 14 years, it's predicted to pay back its embodied carbon, so it will actually become a carbon neutral building in its entirety. We're also working with retailers, so working with a major retailer in the UK, a supermarket, and we've been looking at their whole operation, including looking at the equipment they use in the stores. And we've set a pathway to net zero carbon for those stores. So we've done their typical design, then we've made optimizations on the performance and basically said how they can move towards net zero carbon, and kind of given them 5 options that can be costed, and they can decide how far on the journey they want to go towards net zero carbon in order to meet their corporate social responsibility targets. One of the major problems that we face, as Horia outlined, is existing buildings. So the target is to be net zero carbon across the entire EU by 2050. But by 2050, we'll only have replaced about 20 to 30% of the building stock. So if we only focus on new buildings, we won't hit that target. What we will need to do is decarbonise all buildings. So if you walk around any city or town, every single building you look at will need to move towards net zero carbon, which means significant work for a lot of existing buildings. And what we've been doing with a lot of our clients is going into those buildings and doing reviews, high-level desktop reviews to basically say, how can we move towards net zero carbon, but also detailed simulation and modelling to work out what the current performance is, and then how we can actually set a pathway down to the net zero carbon targets. And that might mean going in and replacing the heating systems to heat pumps, upgrading the fabric to make it more airtight and add more insulation, looking at making the buildings naturally ventilated with mixed mode ventilation, as I mentioned earlier, and also looking at the behaviour change of the occupants. So it's a significant piece of work which is going to require significant effort globally in order to decarbonise the massive amount of buildings that we currently have. And the way we do this is using our 7 steps. So again, going into a lot of buildings and just basically scoring it against passive design, operational energy, fossil fuel use, renewables, and basically saying how close is it to achieving net zero carbon, and then making a list of recommendations and interventions which can be done. Some of them are quick wins and easy to install, others require significant works and significant costs which need to be factored into the life cycle of that building. So off the back of doing this over the last couple of years, Cundall have put together some bespoke services, and we're able to help now organisations decarbonise their buildings. So that's both new and existing buildings, looking at energy in use and also looking at the embodied carbon and whole life carbon. We also help large landlords and funds with portfolios or estates. So that's setting strategies across an entire portfolio of 10, 20, 100, 1,000 buildings. And what's really important when we're looking at portfolio level is really understanding where to prioritise effort. It's not a case of just taking each building individually. It's looking at the data in its entirety and focusing our attention where we can get the greatest savings as quickly as possible. And we can also help at corporate level, so looking at carbon footprinting of organisations and carbon neutral certification. So as Horia indicated, we're just finalising our carbon neutral certification for Cundall, but we're working with at least a dozen organisations to help them achieve their own certification. And I'll just finish up with a call to arms. So we've seen that climate change is really starting to affect the world. We're seeing emissions rise, we're seeing sea levels rise, we're seeing forest fires, flooding globally, and these things have started to have a huge financial and human cost. And if we don't act, they're going to become more frequent and the cost of them will mount up. So we really need to start to take action to reduce these effects of climate change going forward. So that's the end of the presentation. Bianca, have we got any questions?
Yes, we do. I'll just start with one. So embodied carbon is a problem with many materials production. How do you see carbon being taken out of cement and steel production?
So cement is probably one of the biggest challenges the construction industry faces. So it's in terms of concrete, cement is generally about 20% of the volume, but it accounts for 80% of the carbon. So anything you can do to remove cement gives significant carbon saving. What we've seen globally is a move towards supplant replacement, so using things like fly ash replacement, and we can generally get up to 50% replacement, and in some cases up to kind of 60 or 70 where it's not needed for its strength. We can actually go to kind of 70%. That has huge carbon savings and makes it generally better than steel. In terms of steel, the main thing is to reduce weight. So it's optimizing the performance of the structure, which most people do anyway for cost reasons, but then it's the selection of steel. So as I mentioned earlier, there's two types of steel generally, which is either blast fired or electric arc fired. And if it's electric arc, they generally use recycled steel, and it's using electricity which they can procure from renewable technologies, which has a significantly lower carbon footprint than using a natural gas fired furnace with virgin ore. So it's about selection of those materials. And also structurally, what's really important is looking at the grid layout. So over the last decade, we've seen a move towards longer span grids, which means generally deeper beams and more material. But what we're seeing in the UK and in Australia is a move back towards regular grids and smaller grids, which are generally lighter and lower carbon footprint.
Okay, thank you. Could you please discuss the potential conflicts with future-proofing against pandemics versus the desire to have efficient buildings, specifically thinking of things like requirements for 100% fresh air, separate on a floor-by-floor basis, additional electrics around touchless solutions, etc.?
Good question. So again, what we've seen over the last 6 months is we thought there'd be a significant reduction in energy consumption of buildings because a lot of commercial buildings aren't operating, but actually they're still operating at a very high base load, generally 70–80% of their normal emissions. That's because we haven't designed them very well to turn down or turn off. And now that people have been reoccupying buildings, we've seen a significant spike in energy consumption because people are turning the ventilation on for 24 hours a day to purge spaces. and they're also bypassing things like their thermal wheel because of fear of cross-contamination or using 100% fresh air as you indicate. So what we need to do is find that balance. We need to be designing systems which can be easily controlled and use smart controls, so they can actually look at the environments inside the buildings and actually call for energy when it's needed, but then throttle back and reduce energy consumption when it's not needed. In terms of ventilation, what we're suggesting for both COVID response and also for net zero carbon is openable windows. So the main recommendation from ASHRAE and SIBSI is that dilution of the air and rapid and air change rates is really important. And the best way to do that is openable windows. So yes, you want your mechanical ventilation system, but you don't need to run it all the time. If you can open windows in support of that, especially when the weather's reasonable outside, then that will go a long way to achieving the benefits.
That's a quick win. Just open a window. Landlords sometimes only have direct power over common areas, not exactly on tenant areas. What's Cundall's view on possibilities of collaboration with tenants, supporting their initiatives, guiding them, green leases, quick wins, especially on a global basis with different markets, practices, and legislation?
Yeah, that's a really big point. And in Australia, where they've been pioneering operation energy for the last decade, they made an important decision to actually break landlord and tenant energy out. So we have energy intensity targets for buildings, but there are separate targets for landlord and tenant. So a landlord can market a building to be net zero carbon for the landlord areas, and then say the tenant has to achieve their own performance. And then working with those tenant engagement, and that's what we're doing with quite a lot of large landlords at the moment, is going in and working with the tenants to reduce their consumption, because again, tenants don't really understand how they can influence this. So that's their selection of IT, how they turn stuff off at night. You'll be amazed at how many PCs are left on at night in commercial buildings and in schools. The base load is significant. Most buildings actually, things like schools and offices actually consume more energy when they're not occupied than when they do, when they are, because there's so many hours that they're not occupied. Most offices actually consume 50 to 60% of the energy out of hours rather than in hours. So there's huge amounts of savings that can be achieved with that engagement. And again, good landlords are offering that to their tenant and recommendations on how they can actually make those reductions.
Okay, well, that was the last of our questions. So if there's no more questions, thank you to everyone that joined our webinar this morning. As I mentioned before, this is going to be recorded and posted on our YouTube channel, and details will follow after this. Hoya, do you have anything to say in the end?
Just I want to thank everyone who attended this meeting, and I hope it sets the terms for a new way of viewing the construction market for the next 30 years from now on.
Okay. Thank you, everyone. Have a good day.
Thank you.
Bye.